Hello, honors geometry classes. Mr. Rivers here. We got to number 6 here in this is the 2.4 notes. We covered this today in class. It's Thursday, September 22nd. I wanted to talk a bit about this last proof here. Everything we did in class holds true, right? There's nothing here that's a mistake. It's very detailed, which is a good thing. I just want to let you know we're not going to require uh, all these steps to be shown in order to receive full credit. So let's talk about what we can take out. I'm going to allow you to take out this second statement here with the angle addition postulate. We were saying RUT plus RUN is equal to TUN. I'm going to allow you to take that out. Also, I'm going to allow you to take out that the measure of angle TUN is 180, TUN is 180. You can take that out. That is true. That forms a straight angle. I'm also going to allow you to take out the measure of angle RUT plus the measure of angle RUN equals 180. You can take that out as well. So let me just do it this way. I'm going to select everything. I'm going to slide it all to the right. I think that works. Okay, so all that can come out. I'm going to set it to the side. And then we're going to take these other steps here and we're going to move them up. There you go. So let me change the numbering here. This will be number 2. And then this will be number 2. This will be number 3. And this will be number 3. So first off, angle JOG is supplementary to RUT. So JOG supplementary to RUT. That was given to us. That's this angle and this angle. They are supplementary to each other. Up next, I said angle RUN, which is right here, RUN, and RUT is right there. They are supplementary as well. Now we need to change this reason. It's not going to be definition of supplementary. It would have been definition of supplementary based off the stuff I took out, but think about how we know RUN and RUT are supplementary. All right, we're going to say they form a straight angle. Like together. Together they form a straight angle. And then finally, angle RUN is congruent to JOG. RUN and JOG must be congruent to each other because angles supplementary to the same angle are congruent. Both JOG and RUN are supplementary to RUT, and angles supplementary to the same angle are congruent. So that simplifies this proof a bit. I just wanted to let you know that. This would be acceptable on a quiz. You're more than, if you provide all this stuff, that's acceptable as well. But I'm just letting you know we're not going to require that on the quiz on Friday. I was going to make a key for the worksheet so you have it in preparation for the quiz tomorrow. And I might as well just work through it on video here so you can watch it. Here we go. Number 1, given that angle E is a right angle, right here, okay, and angle F is a right angle, right there. Our conclusion is angle E is congruent to angle F. That reason, well, these are both right angles, and all right angles are congruent. That's a reason it shows up a lot in proofs. All right angles are congruent. Second problem, given that B and C are trisection points of AD, well, the conclusion is going to be AB is congruent to BC, which is congruent to CD. AB, segment AB, is congruent to segment BC, which is congruent to segment CD. How do we know that? That's the definition of trisect. Okay, up next, number 3 here, we got a new figure. Looks like triangle GKJ, and we have angle 1, angle 2 that is formed by segment GH. So we're told that GH is perpendicular to JK. Think about what it means for one segment to be perpendicular to another. It means that right angles are formed. So we'll say angle GHJ, and angle GHK are right angles. And the reason for that is definition of perpendicular. Definition of perpendicular. All right, this next one, we actually don't even need the figure for this. So pretend the figure is not there. J is complementary to angle 1, and angle 2 is also complementary to angle 1. So when two angles are complementary to the same angle, that means those two angles must be congruent. So our conclusion is angle J is congruent to angle 2. And the reason is, all right, think about this, pause the video if you haven't done it already. Angles complementary. Now, is it going to be to congruent angles or to the same angle? Think about that. These two angles, J and 2, are they complementary to congruent angles, or are they complementary to the same angle? And they're both complementary to angle 1. So angles complementary to the same angle are congruent. Yes, you have to write that whole reason out. You can do some abbreviation like I did. Complementary COMP, congruent CONG, that's fine, but I need to see all that there. All right, so on example 5, we actually don't even have, or number 5, we don't even have a figure for this, and that's okay. Angle 3 is supplementary to angle 4. Angle 5 is supplementary to angle 6, and we know that 4 is congruent to 6. So 4 is congruent to 6. Well, 3 is supplementary to 4, and 5 is supplementary to 6. Therefore, angle 3, which is right here, has to be congruent to angle 5, which is right there, and that reason is angles supplementary to, all right, now is it going to be the same or is it going to be congruent? The same angle or is it congruent angles? Well, 4 and 6 are congruent, right? Angle 3 is supplementary to angle 4, angle 5 is supplementary to angle 6. Compare that to the last problem. These were both complementary to angle 1. These are angles supplementary to congruent angles are congruent. Angles supplementary to congruent angles are congruent. There you go. Number 5. Number 6 here. The supplement of an angle exceeds 3 times the complement of the angle by 40. Find the angle. So first ask yourself, how many angles are there here? 1, 2, 3, 4, 5, how many? 3, right? There's the angle, which we're going to call x. There's the angle, which is x. There's the supplement, which I'm going to hold a place for it. I'm not going to read the problem yet. 180 minus x, and the complement, which I'm going to hold the place of the complement using 90 minus x. So with all that, let's read the problem again, and we're going to adjust one of these depending on what the problem says. The supplement of an angle, okay, so that's this one right here. It exceeds 3 times the complement of the angle by 40. So we're going to change the supplement. The supplement, a lot of stuff is happening to that. The supplement of an angle exceeds, that means we're going to be adding 3 times the complement. That's 3 times. The complement is 90 minus x by 40. So we add 40 to that. There you go. And we can simplify this a little bit by distributing. 3 times 90 is 270. 3 times negative x, that's negative 3x plus 40. And then 270 plus 40 is 310 minus 3x. So there you go. There is the supplement. Find the angle. So now that we have our angle, which is x, we have our supplement, which is 310 minus 3x, and we have our complement, which is 90 minus x. We need to find the angle. So we need an equation. One equation is enough. I'm going to use the angle and the supplement. Well, that would be the angle x plus the supplement 310 minus 3x equals what? An angle and a supplement have a sum of 180. Okay, x minus 3x is negative 2x. That is equal to, we subtract 310 from both sides, and we get, that is negative 130. And you divide both sides by negative 2, and x equals 65. So the angle is 65 degrees. All right, next one. Angle A is supplementary to angle C. Angle B is also supplementary to angle C. So right away, you need to be thinking, okay, well, if A and B are both supplementary to angle C, that means angle A must be congruent to angle B, because angles that are supplementary to the same angle are congruent. So A is 7x minus 19. That is equal to angle B, which is 4x plus 11. I'm going to subtract 4x on both sides, giving me 3x on the left. I'm going to add 19 to both sides, which gives me 30 on the right, and x equals 10. X equals 10. So that is not what we're asked to find, though. We're asked to find the measure of angle C. Well, remember, A and B are both supplementary to angle C, so let's find the measure of either A or B. I'll find the measure of angle B. That's 4 times x, that's 4 times 10, which is 40 plus 11. 40 plus 11, the measure of angle B. Measure of angle B is equal to 40 plus 11 is 51 degrees. So now the measure of angle C, remember these are supplementary or complementary? Be careful here. Sometimes people just assume they're complementary. If you read the problem, they're actually supplementary. So the measure, let me do this in blue. The measure of angle C equals 180 minus 51. So the measure of angle C is equal to, was that 129? 129 degrees. If you think back to the beginning of this video, I said, okay, we can take this extra stuff out. I shouldn't call it extra. It's extra detailed. It's not extra information. It is just extra detail, which is a good thing, right? And you're happy to, or I'm happy to have you show all this work. But if you remember what we said for this one of our reasons was we said angle RUN and angle RUT are supplementary. RUN and RUT are supplementary because they form a straight angle, right? That was a reason that we used there. And a similar reason shows up in this next problem here as we are working the proof. We've got AB perpendicular to BC. So angle 1 and angle 2, they form a straight angle. So we're going to use that. We're going to say angle 1 is complementary to angle 2. They form a right angle. I think I may have just said straight angle. They form a right angle. Same thing for 3 and 4. When DC is perpendicular to BC, that forms a right angle right there. So angle 3 and angle 4 are complementary because they form a right angle there. Also, we're told that angle 2 is congruent to angle 3. We'll get to that in a second. We're trying to prove that 1 is congruent to 4. So we know this is going to be our last statement. Angle 1 congruent to angle 4. Let's see how we get there. Let's start with our given information. I'm just going to pause the video while I write this down. First off, AB is perpendicular to BC. Let's draw a conclusion from that. We know that angle ABC is a right angle. Okay, and that reason is going to be definition of, what do you think? Remember to look up and to the left if you're ever confused. This doesn't help you 100% of the time, but it helps you a lot. It's definition of perpendicular. Okay, back to our given information. DC is perpendicular to BC. That's given. What does that tell us? Let's build upon that. Well, if DC is perpendicular to BC, that means angle DCB is a right angle. And that reason is, see if you can guess it. Definition of, same as before, perpendicular.